Right, this is a predicted paper 3. It's a calculator paper for June 2025. Once again, there's no guarantee that any of this is going to come on paper 3. It's just my best guess based on what's not been assessed on papers 1 and 2. Good luck with this. Let's do it. Some rounding questions to get us going. 3091 to the nearest 100. There's your hundreds. We draw a line there. And the 9 is going to push that 0 up to the 1. So that's 3,100. It's closer to 3,100 than it is 3,000. Part B, nearest 10. So we've got hundreds, tens, and units. There's our tens. It's 356. The 6 is going to push the 5 up. So it's closer to 360 than it is 350. And then finally, 1 decimal place rounding. There's my decimal point. There's the first decimal place. That 5 is going to push this 0 up to a 1, so you get 356.1. There's your 1 decimal place rounding. Question 2 says, write 490 as a product of prime factors. That's this thing, the tree diagram. And we're looking for 2 numbers that times to make 490. It is a calculator paper, so just start hitting divide on your calculator if you're not sure about this. 490 will divide by 10. 49 times 10 is 490. I'm going to keep going because none of those are prime. 7 sevens are 49 and they are both prime. What I mean by that, I can't divide any further. I'll just get 7 and 1, 7 and 1, 7 and 1. So stop there. 10 is not a prime number, so I can keep going. 10 is 2 times 5. 2 is prime. 5 is prime. They are all my prime factors. Don't miss this final mark. Product means multiplication. So I'm going to write 2 times 5 times 7 times 7. 2 times 5 times 7 times 7. In this question, that's full marks. If it said index form, there'd be an extra mark for saying 2 times 5 times 7 squared. That's your index form right there. This doesn't say it, so I wouldn't lose a mark if I didn't do that. Question 3, we've got an angle to measure. You're just going to grab a protractor. Just make sure your 0 line goes there and you're reading from 0. Don't read from the 180 part of the protractor. I can't do this live, but I think it's around 43 degrees. Somewhere 43, 44, 45, something like that. Just make sure you're reading from the 0 line, not from 180. Type of angle here, it's either acute, obtuse, or reflex. That is an acute angle. Anything less than 90 degrees is acute. If it's between 90 and 180, it's obtuse. And if it's more than 180, then that's your reflex angle. We're looking at 2 lines here. These funky little arrows, they mean parallel. Just like your train tracks, okay? Anytime you see those 2 little arrows on the lines, you are looking at parallel. Question 4, we've got a circle and we just need to know the parts of the circle. So part A says draw me a diameter. A diameter goes from one side to the other and it must go through the centre. So there is your diameter. Part B, apologies if you got the early version of this. It said something like a minor sector. This is the only question on the entire paper that I actually wrote myself and I messed up, so I'm so sorry. A segment is like a segment of an orange. So that is a segment right there. You would get full marks for colouring the other segment in. Okay, this big shape here. They are both segments. One's a minor segment, one's a major segment, no matter. Just go for the small one if you're ever unsure. If you looked at the question before and it was talking about sectors, the reason I changed it is because there are no sectors on this diagram. A sector is like a pizza slice. So sorry about that. Part C of this question, write down the mathematical name of the line that was originally drawn. So that one there, that black line that was drawn in, that's called a chord. I put this question in because they're the 2 worst things they could ask you about circles. Segments, chords. The only other one you might be asked about is this line, and that's a tangent. So just a bit of information there. They're the worst things they're going to ask about circles. Just make a note of them if you're unsure of those 3. Question 5, my mates Lev, Maria and Nicholas, they're sitting in seats. And we've got to show all the different possibilities that they could sit next to each other. So what I like to do is, if I can, keep the first thing the same and then just swap around the other 2. We've got to find some way of making sure we get every combination. Now, there's no other ways to swap these 2 around, so I'm going to have to put something else at the start. So I would just go to the next letter and put M at the start. And then I'll just put the other 2 letters in place. And then again, keep your first letter the same if you can, and swap the other 2. So I've got L, L, M, M. It must now be N at the start. And again, just put the other 2 letters in place. And then keep your first letter the same and swap the other 2. And this looks sensible because I've got 2 L's, 2 M's, 2 N's. I think that's every possible combination for these 3 people. Part B says all possible orders in which they could be sit are equally likely. That's just covering it back in terms of probability. What's the probability that Lev sits next to Maria? So we just need to find those. There's Lev and Maria sat next to each other. There's Lev and Maria sat next to each other. There they're sat next to each other. I don't think there's anywhere else where L and M, there is right there. Lev and Maria sat next to each other. There are 4 ways that they're sat next to each other, and it's out of 1, 2, 3, 4, 5, 4 out of 6. It doesn't say simplify, so there's no need to, but if you did, you'd get 2/3. Both are correct, and there's no extra marks for simplifying in that question. Question 6, we've got my mate Morgan playing a computer game, and they get 0, 1, 2, 3 or points. They have 100 goes on this game, and then we've got something called relative frequency. Relative frequency is just probability, but it's probability based on something they actually did. All right, we'll explain that in a second a bit better. What we need to know about relative frequencies, like all probabilities, they add up to 1. So what I can do to fill that table is just say, right, 0.08 added to 0.42 added to 0.38. It is a calculator paper, and that comes to 0.88. If all these things add up to 1, then I'm going to do 1 take away 0.88, or just 1 take away answer that's in my calculator, and that comes to 0.12. So that missing box there is 0.12. Part B says my mate Morgan says he scores 160 points or more than 160 points in the 100 turns, and we need to know if they're correct or not. As I said earlier, relative frequencies are just probabilities. So imagine these were fractions, they'd be easier to understand. If, let's say, this fraction was a quarter, still a probability. What we'd say is a quarter of the time, a quarter of the 100 turns, we scored 0 points. Now, they're not fractions, they're decimals, but they're the same thing. Fractions are decimals. So what I'm going to do is say for this thing here, not a quarter of the time, because that's not the fraction or the probability, but 0.08 of the time, I score 0 points. So I'm going to do 0.08 times 100, which is 8 times we score 0 points. We'll look at the next one, it might become more clear. How many times do I score 1 point? Well, like I say, if that was a fraction, we'd just do a fraction of the 100 turns. It's not a fraction, but I can apply the same maths, not a half or a quarter. 0.42 of the 100 times, I score 1 point. So I'm going to do 0.42 of the 100 times. 0.42 times 100 is 42 times. And 42 times, I'll get 1 point. I'll keep following this through. 0.38 of the 100 turns, 0.38 of the 100 turns is 38 times. I'm going to get 2 points. And then we've got one more to do. I'll stay in this funky colour. 0.12 of the 100 turns, I get 3 points. Just change that. 0.12 of the 100 turns is 12 times. And that's when I get 3 points. So this is just working out how many times I get a certain amount of points. And I just need to convert this into points. Well, 8 times at 0 points is still 0 points. 42 times getting 1 point is 42 points. 38 times getting 2 points, 38 twos is 76. And 12 times I got 3 points. 12 threes or 3 12s are 36. If I add all those together, then that's 154 points. That's what Morgan gets. Is Morgan correct in saying they got more than 160 points? No, my mate Morgan is wrong. Question 7, we've just got a shape, a polygon. It's got 1, 2, 3, 4, 5, 6 sides. That is a hexagon. Even though it doesn't look like a standard hexagon, 6 sides, or 6 edges I should say, that's a hexagon. Order of rotation for this polygon or this shape. Imagine you're spinning it around. We want to know how many times does it look exactly the same. Well, imagine this flat bit coming to the top. It happens once. This is the same flat bit, so that'd be twice. And this is also the same flat bit, 3. So every time that flat bit gets to the top, this shape looks exactly the same. That is your rotational symmetry. It happens 3 times. Question 8, just got some types of number work. I know this stuff's been already, but it comes on most papers, this. What is an odd number? Odd numbers are 1, 3, 5, 7. So any of those is good. A factor of 25, any numbers that times to make 25 are factors. You've got 1 times 25, 5 times 5. So again, any of those numbers are factors of 25. Your prime numbers, a bit more difficult. Prime numbers are numbers that only divide exactly by 1 and themselves. It's a bit rough that, but I'm showing you what I mean. So 22 is not prime because it'll divide by 2. 23 is prime because I'm trying in my head now to divide it by things. It won't divide by 2. It won't divide by 3 exactly. It won't divide by 4. 23 will only divide perfectly by itself and 1. There's your prime number. And then show that 55 is not a square number. Well, your square numbers are these things. 1 times 1 is 1 square. 2 times 2 is 4 square. We can keep going with this, and what you'll get is 7 times 7 is 49 square. And if we do the next one, 8 times 8 is 64 square. So if you've got 49 is a square number and 64 is a square number, 55 is not a square number. You're showing the square numbers on either side of that number, which is not square. Question 9, some basic fraction work. It don't come up a lot, but it could do. What fraction is shaded? We've got 2 parts out of 3 parts, so 2/3. And then this is a bit more challenging, but it's saying what percentage is shaded. Well, we've got 1, 2, 3 parts out of 4 parts. Some people just know that 3/4 is 0.75. If you do 3 divided by 4, remember this is a calculator paper now, you will get 0.75. If you then hit times 100, you'll get your percentage, which is 75%. 0.2 as a fraction. Anytime you're turning a decimal to a fraction, it'll be out of 10 or 100 or 1,000. Your calculator will do this for you, but may as well do it without a calculator at this point. Just count how many digits after the decimal point, and that's how many zeros you want. So this is 2 out of 10, or 2/10. And then finally on this question, what is 80% of 30? There is a percentage button on your calculator, so you can just do that. 80% times 30. If you don't know the percentage button, you can just do 30 divided by 10. That will give you 10%, and then times 8 gives you 80%. So 30 divided by 10 will give you 10%, and then times 8. That comes out at 24. Question 10. Some brackets to expand. Multiply out is the same as expand. Could be either instruction. And all it means is start timesing things together. So we're going to do 4 times 3x and 4 times 2. 4 times 3x is 12x. And 4 times positive 2 will be positive 8. Factorising is going the other way. I'm going to try and put this back into brackets. So we need to know what goes into 3 and 6, or what's a common factor of those. 3 goes into 3, 3 goes into 6, open some brackets. And then we're saying 3 times something is 3c. Well, 3 times c is 3c. And 3 times something is negative 6d. 3 times negative 2 is the negative 6. But I want a negative 6d, so 3 times negative 2d is negative 6c. You can always double check. Expanding is always easier than factorising, so just re-expand. You'll get 3c minus 6d. Yeah, but just make sure you're showing that's your final answer. And then we're going to factorise. And then we're going to factorise this same thing. What's a common factor of 5 and 10? Or what goes into 5 and 10? The answer is 5. But now we've got letters as well. What goes into x squared and x? A single x will go into both of those. Open some brackets. 5x times something is 5x squared. 5x times x is 5x squared. And then 5x times something is 10x. 5x times 2 is 10x. So your final answer looks like that. 5x lots of x plus 2. Question 11, we've got some percentage work to do. We're going to decrease, so come down by 40%. Lots of ways to do this, and you've got a calculator, don't forget. So I'm going to do it the old school way. I'm going to say, well, 650 divided by 10 is 65, and that is 10%. So 10% is 65. I can then say 40%. All I'm going to do is hit times 4 on my calculator. So 65 times 4 is 260. Now be careful, 40% is 260, and this is a decrease or a come down by 40%. So I need to start with my 650 and take away the 260. I'm not just finding 40%, I'm coming down, I'm decreasing by 40%. And if I bash that into a calculator, I get 390. There's lots of ways to do that, guys. You might know how to use the percentage button. You might have said, why not just find 60%? All good. I'm just talking you through a method that I think shows you a lot of maths at the same time. So question 12, we've got some more percentage work to do. Again, we've got an amount and we're coming down by a percentage. So we're coming down by 20%. I'll do this a separate way just in case you do know how to use the percentage button on your calculator. What I'm going to do is type in my calculator 750 times 20, and there is a percentage button. You might have to press the shift key to get it, but there is a percentage button on your calculator. And that comes out at 150. Now remember, we're coming down by 20%, so I need to do 750, take away that 150 that I just found, and that would be 600. It then says there's a final day of this sale, and we're reduced by a further 12%. Now that's 12% of this. So what I'm going to do is start again and say, right, now I've got 600 times 12, and again, just using the percentage button on my calculator, and that comes to 72. Again, we're reducing by 12%. We're not finding 12%, so I'm going to do 600, take away the 72, and that comes out at 528. So this here is the final cost of the computer. You've got to be super careful. It says how much is saved by buying on the final day. So we've got to work out the saving. We started at £750. We're now at 528. If I want to know how much is saved, that's a subtraction. And again, all on a calculator, that just comes out at £172. That is how much I actually saved by not paying this, but paying this instead. Question 13, some more percentage work, I'm afraid, and I'm going to keep using the percentage button on my calculator because why not? It's the easiest way to do it. So we're starting at £500, and this time we're increasing by 25%. So I'll start with 500. I'll multiply by 25, again, using percentage button on my calculator, and that's going to come out at 125. So that is 25%, but remember this is an increase. So I'm going to do 500, add 125, and that is £625. That is the increase of 25%. It then says the price drops to 500 again. What is the percentage decrease to get me back down? So first thing I'm going to do is say, right, we're at 625. We're going back down to 500. So let's figure out how much I've dropped by. You know what? I knew that already. It's coming back down by £125. I need to work out what that is as a percentage of this. So if we want a percentage, let's start with a fraction. I'm coming down by 125 out of 625, not 500 out of 625. Now if I want to change this to a percentage, I'm going to do top divided by bottom, 125 divided by 625, and then times 100. That's how you change a fraction to a decimal to a percentage. So again, all on a calculator. And that is a 20% decrease. Question 14, we've got some biscuits to be munched, and we're trying to find which is the best value. So there's loads of ways again to do this. I'm just going to go for the bog standard way. On this left-hand side, we've got 20 biscuits, and they cost £1.50. Now, what I'm going to do is just go bog standard, something that will work every time, figure out what one biscuit costs. So to turn 20 into 1, I'm going to divide by 20. And I'm going to do the exact same on this side. You could find out what 10 biscuits cost, whatever. Always come down to 1, it'll work every single time. So I need to do £1.50 divided by 20, which comes out at 0.075. Horrid, but correct. Let's go over onto this side. We've now got 24 biscuits, and they're costing £1.80. Again, I'm going to come down to 1 biscuit because that'll work for every question. 24 to 1 is divided by 24. So over on this side, divide by 24. Bash that into a calculator. And we get 0.075. So that's the cost of 1 biscuit, which is actually the exact same on both sides. It doesn't often happen like that, but it can do. My mate Nada says the packet of 24 biscuits is best. Is she correct? No, they never correct these people. Why? Well, your working above shows that they're the same value. Okay, it's the same cost per biscuit, so they're exactly the same price. Question 15, my mates Anna and Paddy are doing a fun run, and we've got Anna did the run in 2 hours. So before I do anything else, I'm just going to look at Anna and say time equals 2 hours. Just pull that information out. It says her average speed was 6 kilometers per hour. So her speed is 6 kilometers per hour. Before I even read the rest of the question, I'm thinking this is a speed, distance, time question. So using my formula triangle, speed is distance over time. What I can do is work out Anna's distance. That's the only thing missing. These formula triangles work by dividing from top to bottom or multiplying across the bottom there. So if I want distance, I'm going to say that is speed times time, which is 6 times 2. That would be 12 kilometers, because kilometers are in the question. If we now look at my pal Paddy, well, he did the run in 90 minutes. So we're going to look at Paddy over here, and his time is 90 minutes. Now that's a problem because Anna's time was in hours, Paddy's time is in minutes. If you want to change minutes into hours, you just need to divide by 60. So we're going to hit 90 divided by 60, and that is 1.5 hours. Some of these funky calculators will have time conversions on them. I'm just going to divide by 60 because that is the standard method. So we know Paddy's time is 1.5 hours. It's the same fun run. So Paddy's distance will be the same as Anna's, which is 12 kilometers. And what we're trying to work out is Paddy's speed. So I'm going to draw my formula triangle again. Speed, distance divided by time. Let's write that down, which is 12 divided by 1.5, all on a calculator. We get 8 kilometers per hour. B, my mate Anna is saying that she stopped for drinks, so her average speed is actually more than the 6 that is quoted above, and we need to say why is she right. So one of the rare occasions when someone's actually right here. So if she's stopping for drinks, then the time keeps ticking while she stood stopping for drinks, and the speed is using all of that time to calculate the speed. So what we can say is something like that. Without stopping, the time would be smaller, so the speed is bigger. If speed is distance divided by time, if your time gets smaller because we don't include them stops, then the speed goes up. And then question 16, we've got a volume of a piece of wood is 620. So volume equals 620. We're told the density is 0.85. So let's get that copied down. Sorry, I've just noticed there's a little error here. That should be centimetres cubed, a tiny little 3 up top. Sorry about that. And we're asked to work out the mass. This is a formula triangle. Again, compound measures. Density is mass divided by volume. We actually want the mass, which is this thing. And again, that's going to come from those bottom things times together. So the mass is the volume times the density, which is 620 times 0.85. And that comes to 527. And this is a grams question. So make sure you get your units there if you're not on the answer line. Question 17 is a bit of a monster. We're looking at a rectangle, and it first talks about perimeter. And perimeter is all the way around this outside. So just because these are algebra, don't forget as normal rules, it's a rectangle, those two sides will match, and then the top and bottom will also match. So you might get a mark just for showing that. You will definitely get a mark if you start to show the perimeter of this thing using your algebra. Well, perimeter is adding together, so I'm going to do x add 3, added to another x add 3, added to the top thing 4x minus 5, added to the bottom thing 4x minus 5, and that's probably got a mark. If we say that comes to 46, we've probably got 2 marks. Just by writing all that stuff added together comes to 46. We can start to tidy this up. But 1, 2, 6, 10 x's. Just adding those x's together. 3, 6, take 5. That'd be 6 take 10, which is -4. And that comes to 46 still. Now this is an equation that we can solve, so let's do that. Let's add 4 to both sides. We're going to get 10x equals 50, and then divide both sides by 10. You're going to get x equals 50 divided by 10 is 5. Now you might think you're finished there. We're not actually finished, because this question says work out the area of the rectangle. Now what I need to do is go back to any of these sides. Now I know that x is 5. I can say, well, this is 5, add 3, which is 8. So that side there is 8. I can now look at this side as well. And if x is 5, this becomes 4 5s, which is 20. Then take away 5, that is 15. So now I can get the area of the rectangle. It's just 8 times 5, base times height for area of a rectangle. So 8 times 15, not 8 times 5. And 8 times 15 is 120. Bash that into a calculator. Question 18, we've got a little equation. It says find the value of y when x equals 10. So this x is becoming 10. So what I'm going to say is, well, 5y is not 4x's anymore, 4 lots of 10. So we can say 5y is 40. X is 10, so I've just put that in there. And if 5y is 40, then y is going to be 40 divided by 5. And 40 divided by 5 is 8. And part B says write y in terms of x. So I'll just do this up here. It says 5y equals 4x. Y in terms of x means I want y on its own. So I'm going to get rid of that times 5 by dividing by 5. And we'll get y equals 4x divided by 5. Nicest way to show divided by 5 is over 5. If you wrote y equals 4x divided by 5, you'll probably still get full marks. Question 19, simultaneous equations, guys, and this one's really nice. It's already set up lovely for us. Often I'll get my x's to match, and I might have to double this one or triple this one, and I might have to times this by something as well. But look at this, it's already set up, whereas y's match. So straight away I can just do a subtraction. 3x take 1x is 2x. Y take y is gone, there's nothing there anymore. And then I just do 11 take 3, which is 8. And if 2x's is 8, then 1x is 8 divided by 2, which is 4. So now I know that x is 4, I can go back to any of these equations at the top. I may as well pick the nice one that says x add y equals 3. I know that x is 4, so this becomes 4 add y equals 3. And all I need to do is now solve this. Well, it looks a bit weird, but if we just take 4 from both sides, you'll get y equals, make sure you do 3 take 4, and not the other way around. 3 take 4 is -1. So I know y is -1 and x is 4. Question 20, we've got 4 mates going on holiday and they've all got a suitcase which is 25 kilograms to the nearest kilogram. Whenever you've got some numbers that have been rounded already, you're looking at this weird bounds type question. So we've got 25 kilograms. We're going to go up to 26 kilograms and down to 24 kilograms. And what I'm looking for is this middle zone. These things are called the lower bound and the upper bound. And all it is the midway between 24 and 25, which is 24.5. This one is midway between 25 and 26. That's 25.5. These here are all the possible weights that round to 25 when you're doing nearest kilogram. Not including 25.5, but we still write it down as the bound. How can we complete this error interval? Well, we just take this smallest value, 24.5, and this biggest value, 25.5. Notice that this actually rounds to 26. That's why we've not got the or equals to there. We have here, but not there. So this is how you would get over that little issue. Part B says the friends pay extra if we go over 102.4 kilograms. Can they be sure that they won't have to pay that? Well, let's say we could weigh this much. I know we can't actually, but we can go right very much up to it. So if we've got 4 friends and all their suitcases actually weigh 25.5 kilograms, let's bash that in a calculator. That still only comes to 102 kilograms. So using the very biggest possible answer, the upper bound, still brings us under this 102.4. So they can be certain that they won't pay extra, and the reason is, even using the upper bound, the biggest possible value of their suitcase, they are still under 102.4. If you use this number, they'd be way under it. And question 21, we've got a graph to draw, and the rule is just y equals x squared take 2x. Don't worry about all this stuff. That's just saying that your x values go from -1 up to 4. It's just telling you what x values are in the table. What we need to do is fill in this gap, which means put 4 wherever you see an x. So what I'm going to do is grab my calculator. I'm going to do 4 squared take away 2 times 4. X squared becomes 4 squared, take away 2 x's becomes 2 4's. And if you put that into a calculator, you get 8. So this number here is an 8. We've then got to draw the graph. So I'm just going to use these as coordinates. I'm going to go across to -1 and up to 3. Across to -1 and up to 3. No is easy. Across to 1 and down to -1. Across to 1 and down to -1. Across to 2 and up to 0. Across to 3 and up to 3. And then across to 4 and up to 8. And what we've got to do is do a nice smooth curve that bottoms out there. Kind of missed it, but we're just about there. And then scoops up through all those. If you get a weird one down here, then that's wrong. Okay, so just watch for that. It usually happens over on the negative side. So that is now the graph drawn. And part C says, use your graph to solve this weird thing. Well, if we compare that to the graph we've just drawn, we've got an x squared minus 2x, and we've got an x squared minus 2x. Here we've got a 2, and here we've got a y. So the y has been replaced with a 2. Y is 2. That's what I'm looking to draw. So here's y. Here's 2 on the y-axis. I need to draw the line straight across there. That is y equals 2. And what we're looking to do is figure out the x values. So all we've got to do is now read downwards and figure out what those two numbers are. This one is 2.8. And then down here, that's a bit harder, minus 0.7, I think. They're the two answers to this equation. We've got a short recording, time taken to complete purchase on a website, and these are the results. So it took 6 people somewhere between 0 and 3 minutes. That's what we're looking at. It took 10 people somewhere between 3 and 6 minutes. We're asked to work out an estimate for the mean. First thing we're going to need is midpoints. We don't know how long these 6 people took, so we're going to assume they all took 1.5 minutes midway between those. And I'm going to do that for each grouping. So midway between 3 and 6 will be 4.5. Between 6 and 9 will be 7.5. Between 9 and 12 is 10.5. And between 12 and 15, 13.5. If you're not sure how to get midpoints, guys, if it's not blaringly obvious, do 12, add 15, then divide by 2. Just half those things added together. And that's where the 13.5s come from. What do we need to do next? We need to multiply these midpoints by the number of customers. So this is all calculator work. I'm just going to start bashing these in now. That comes out at 9. That'll be 45. So I've multiplied number of customers by midpoint in each row. What I'm going to do now is add all those numbers together. 0.5. I'm absolutely buzzing. I've done all that work. I'm close to the end. Beautiful, beautiful, beautiful. This is where most of you, or at least half of you, will make a mad mistake, because you're going to take your 133.5 and say, oh, there's 1, 2, 3, 4, 5 rows in this table. You're going to divide by 5. You're going to do all that work and lose the final answer mark. When you're calculating the mean, you add things together. That's what this step is being to achieve. And then you divide by how many people or how many things there are, not how many rows in a table. If you add all these numbers together, you will see there are 25 people. That is what you divide by. How many people, not how many rows. And you get 5.34 seconds. Makes sense between 0 and 15. If you're divided by 5, you're probably going to get an answer that's bigger than 15. How can your average be bigger than the maximum? It just can't happen. So there's your final answer there. Part C says, why is it not possible to use the information in the table to calculate the exact mean? And it's just looking at these times here, and you can write something like, you've no idea what each person took in terms of time. They took between 12 and 15 minutes in that last row. Who knows what time they actually took, so we can't get the exact mean. Question 23, we've got something called a time series graph. So we've got time on the bottom and then kind of a usage of electricity up the side. And all we're asked to do is explain why this graph is dodge. Well, I think the first reason, if you always just check your scales and what you're going up in, we start in years and then we go in months. So let's just write that. So that's the first reason it's dodge. And then if we look at this scale, there's no numbers. So another reason there. So it's a pretty naff graph, to be fair. And question 24, function machine. These are quite nice to work with, especially if we've got a calculator. We've got a number goes in, times by 5, take 3, and number comes out. The only thing I will say, at every step of this function machine, press equals. Just make sure you're figuring out what happens before you put the next thing in. So what's the output when the input is 7? We're going to do 7 times 5 and press equals. That's 35. We're then going to do 35, take away 3 and press equals, and that's 32. Just on your calculator, make sure you hit equals at every single point, otherwise your calculator might mess you up. We're then going the other way around. The output is 42, so now 42 is over here, and we've got to go the other way and do the opposites. So I'm going to start with 42. Rather than take 3, I'm going to add 3, the opposite, press equals, you'll get 45. And then I'm going to keep coming this way, and rather than times 5, I'm going to divide 5, the opposite. 45 divide 5, press equals, that is 9. And part B, we've got x going into this function machine and y coming out. And it says write an equation for y in terms of x. So x is going in and we times it by 5. If x goes in and we times 5, we get 5x. Then we're going to take 3. So we've got 5x and we're taking 3. We've just got 5x take 3. You can't do anything with that. You're timesing by 5, then taking 3. And that is y. That's your output. So I'm just going to write that a bit neater. Y is 5x's take away 3. Question 25, we've got people, my mates, painting a fence in a certain amount of time. And we've got 4 people and it takes 3 hours. Be careful with these. It says that we all paint at the same rate. How long would it take just one person? So what we've got to think, all right, we're coming down to one person. If we've got less people, it's going to take more time. Just slow down on these. Less people working must take more time. I'm dividing by 4. 4 divided by 4 is 1, which means on this side, it's 4 times as long. It would take 12 hours for one person to do it. Makes sense. Less people takes more time. Part B, we're going to carry on using the same diagram. We know what one person takes. Now we're scaling up to 5 people, which means we've got 5 times as many people. If we've now got more people, it's going to take less time. So I'm dividing by 5. 1 times 5 is the 5 people. 12 divided by 5 on a calculator is 2.4 hours. So I'm just going to jot that down, 2.4 hours. Now we know that's 2 hours, but we need to come to minutes. If you're ever stuck with minute and hour conversion, it's going to be the number 60 that you need. So what we've got is 0.4 hours, and in every hour, there are 60 minutes. So we've got 0.4 lots of 60, which comes out at 24, and that's 24 minutes. So it's 2 hours and 24 minutes. Like I say, if you're ever stuck with your time conversions, particularly hours and minutes, you're going to be timesing by 60 or dividing by 60, and then just think which one makes sense. And final question on this paper, we've got a prism and a cube, and the first lines are just talking about these shapes. This here says the volume of the prism is the same as the volume of the cube. So let's do the volume of this prism. What we're going to do is work out the area of that triangle, and area comes from base times height divided by 2. Area of a triangle, base times height divided by 2. And that comes out at 96 centimeters squared. Now that's the area of the face. If I want the volume, I now need to times by that length. So I'm just going to hit times 18 on my calculator. And we get 1,728 centimeters cubed. That is the volume of the prism. If we keep reading the question, it says the volume of the prism is equal to the volume of the cube. Now, the special thing about a cube is this, and this are all the same. So if I just call that x, something times something times something is 1728. So I can write that down. X cubed is 1728, the same volume. I just need to work x out, and the opposite of cubing is that weird little cube root. And there is a button for that on your calculator. So I'm just going to find the cube root of 1728, which is a nice 12. So what I now know is that each one of these sides, edges I should say, is 12. We're actually looking for the surface area of the cube. So it says surface area of the cube. So what I know about surface area is it's the area of all these faces that you can see. There's one, there's another, there's one at the side. So let's just focus on one to start with. I know that this area is just 12 times 12, and that's 144. So I've worked out the area of one of those faces. I know on the cube, there's 1, 2, 3, and then there's 3 more that I can't see. 6 altogether. If you just hit times 6, or 144 times 6, that is your surface area, which is 864 centimetres squared. Not an easy one to finish with, but that's just explaining quite a lot about volume and area. Guys, I hope you enjoyed this paper. Like I say, there's no guarantees that any of this will come up on paper 3. This is just my best guess based on what's not been tested in papers 1 and 2. Go and have another look at my paper 2. There's plenty on there that didn't come up, so I would get used to that as well. I would have a look at what's on there and just make sure I'm comfortable with that as well. Good luck. Final paper on maths. You got this.